In this short video, we'll begin our journey into statistical inference, and we'll cover some definitions and part of the framework that's important to learning and talking about this topic. So let's begin with this diagram again. So you already understand the distinction between a population and a sample, and in particular that populations can be clear and finite, such as say a population of medical students in the UK, and that populations can be notional or have only conceptual existence, such as an experiment where the object is to understand the true natural behaviour of something, the true behaviour being the population. So the goal of statistical inference is to make statements about the population using a sample of observations. And the idea of inference, I think, is fairly intuitive to grasp. It's one statistical term that coincides with its literal definition, and it also coincides with the way we humans think and behave. So for example, take for instance tasting food while cooking, or perhaps channel surfing to find a program to watch, or maybe trying to find the quickest route to work in rush hour. In all these examples, we're taking information from a sample and making inference to a population. It's an inductive process from something smaller to something bigger.
In practice, we use statistical inference to answer questions like, what's the best estimate of the relationship between smoking and fetal growth? And secondly, how certain am I of my estimate? What's the range of values over which I can be 95% confident that the true value or the true relationship lies? And lastly, we might do a hypothesis test, and that answers the question, could this relationship I've observed be just due to chance?
So there's some terminology and structure to cover that I think will make your life easier as we go deeper into the topic, and that's the notion of population parameters and point estimates. So the features of the population that we're trying to understand we refer to as population parameters, or just parameters, and these are unknown, and we use a sample to make a best guess at the value for this parameter. Our best guess is estimated using a sample statistic, and we call that the point estimate, or just the estimate. A point estimate is an observed value, a parameter is an unknown value. And typically we tend to use Roman letters to indicate point estimates and Greek letters to depict parameters. The term point estimate sounds new, but as we just alluded to, it's just another name for a sample statistic, which you've already come across in the section on exploring data in a sample. So we use the term point estimate in statistical inference to reflect the fact that it's a single estimate of something else. That something else being the population parameter. And that is taken from some sort of sample. So this table shows two common sample statistics which might be used as point estimates for a population parameter. So let's connect them with a simple example. Say for instance we're interested in the mean height of men in England. So we take a random sample of 2,000 males, and the sample mean would be our best guess of the mean in the population. In this case, the sample mean is called a point estimate of the population mean. Population parameters can be almost any quantifiable feature of the population we're interested in estimating. And this is really to say that they don't have to be connected to those sample statistics that we learnt about when describing distributions of variables, for example means, standard deviations, proportions, etc. We can estimate any parameter we wish as long as the sample enables us to calculate a statistic that can be used as a point estimate of that parameter. So for example, other common parameters might be the difference of two population means, say between two experimental groups, or the relationship between two variables, which might come from a correlation coefficient or a regression slope or coefficient in an observational study, say. Or maybe even the difference in risk between being exposed versus not being exposed to a factor. In all cases, we just calculate our point estimate from our sample, and this is an estimate of the true unknown parameter in the population. So these are the new terms we've introduced in this video.